Okay, 48.1. So you see that the headings is pretty long for this chapter. So let's have a look. What is it? So first of all, for bonding, you know that it will be ionic bond, covalent bond, things like that. Stoichiometric composition. It looks weird, okay? It looks complicated, but actually it means that the atomic ratios in a compound. For example, it is NaO or Na2O. The ratio is different, and we call these, okay, the stoichiometric composition. And then we're going to talk about the acid-base properties of the oxide of the elements in period 3. This time we just focus on the elements in period 3. That means starting from sodium all the way to chlorine. They will form oxide with the oxygen. And then we'll have a look of these oxide. What are those properties in it? Okay. So before we move on, okay, first of all, I just want to record your memories, okay, about these data. So what are these data? They are all En. En what stands for? Electronegativity. So you can have a look of the electronegativity of all the elements in period 3. You can see that, okay, from left to right, okay, the En are increasing bit by bit. What does the value of electronegativity shows? It shows that, okay, the power of an atom to attract the bonding electrons. So you find that, okay, if the En is very small while the En is very large, the large one will have a stronger power to attract the electrons. They will more likely to gain the electron, but for this one, they will lose the electrons. So you will find that if Na going to combine with O got higher En, then the electron will completely transfer to that. So you will find that, okay, for the one on the left hand side, more likely they're going to form ionic bond. The electron transfer, okay, from the metal one to the non-metal one. While the one on the right hand side, okay, they are more likely to form covalent bond. Actually, there is something in the middle, okay, ionic bond transferring to covalent bond, okay. In this transition, okay, the one in the middle, we'll call that ionic bond with covalent character, okay, ionic bond with covalent character. Okay, so you just need to pay attention for that. Okay, is the electronegativity increase across the period, and the nature of bonding when they go from left to right, they become less ionic but more covalent. Okay, so for these oxide of period 3 elements, we're going to put it in a table form, just like this one. Okay, so this table will shows the properties of the oxide of period 3. You can find that first of all, you're going to have the name, stoichiometric composition of the oxide. So each of them, the sodium, magnesium, aluminium, they will form maybe sometimes more than one compound. Like the sodium, they got sodium oxide, they got sodium peroxide. Magnesium got magnesium oxide, and so on and so forth. Okay, so you have to recognize the name, like phosphorus trioxide, phosphorus pentoxide, like sulfur dioxide, sulfur trioxide, dichlorine monoxide, and dichlorine heptoxide. So these are the name of them, okay? But among these kind of oxide, we'll just focus one of the each elements. For examples, okay, for the sodium, we're going to focus on the sodium oxide only. Magnesium oxide is the only one. Aluminium oxide, silicon dioxide. For the phosphorus trioxide, we're going to talk about the phosphorus pentoxide. And for the sulfur dioxide, we'll focus on sulfur. We're going to focus on the sulfur dioxide. And the last one, we're going to focus on dichlorine monoxide only. So for the other one, okay, you just need to know that, okay, they may form more than one form of oxide will do, okay. So as mentioned before, okay, for the structures, okay, for this kind of oxide, the structure of them, for the first 3 of them, they will be in giant ionic structure because they're ionic bond. The ionic bond right here. You see this one, predominantly ionic. Actually, it is the same as the ionic bond with covalent character. So these are the ionic bond forming giant ionic structure. Silicon dioxide, if you remember, they are having GCS structures. Okay, GCS structures, so far you learned 6 of them. Okay, so we got graphite, diamond, sand, quartz, silicon dioxide. This is what you learned in chapter 9, and last one that you've learned in previous chapter, that will be boron. Okay, so silicon dioxide, we have giant covalent structures. Okay, and for the rest of them, okay, the phosphorus pentoxide, sulfur dioxide, and also dichlorine monoxide, they're having covalent bond and simple molecular structures. So as what we've mentioned before, we'll focus on the highlighted blue one. Okay, we're going to see what acid alkaline properties do they have. Okay, but one more thing, just want to draw your attention to, that will be the color of this substance. Okay, most of the times, okay, those are white solid, okay, for the one on the left hand side, but for the one on the right hand side, we got two gases right there. Okay, one is sulfur dioxide, one is dichlorine monoxide. Okay, so for sulfur dioxide, it is colorless gas, while the sulfur trioxide, it is colorless liquid. Okay, for sulfur trioxide, actually it have a very low melting point and boiling point as well, a very narrow range only. So sulfur trioxide, sometimes it will be, if you just boil it a little bit, they will turn into colorless gas as a serious acid pollutants as well. Okay, so for the dichlorine monoxide, it is orange gas. We don't have much orange gas actually. Okay, we just have the reddish brown gas which is coming from the bromine. Okay, but for the dichlorine monoxide is the only orange gas that we've learned so far. Finally, okay, is the dichlorine heptoxide, with that is colorless liquid. Okay, so again, okay, just focus on the blue molecules. Okay, will be more than enough. Okay, for this chapter. Okay, just have a quick look of the exercise. Okay, so right here you got A, B, C, D. Okay, they are not chemical symbols. Okay, don't mix up, it is carbon. They are mainly, okay, elements from period 3. Okay, and then we can have a look. Okay, so the most important information that we can see will be the electrical conductivity. Okay, because you can see the first one, they can conduct electricity, while the others, they cannot. So these three of them more likely will be GCS or SMS, while the first one will then be GIS, giant ionic structures. Or as is a GIS, so you know that it is a giant ionic, you have an ionic bond in between. So if we reverse the charges, then we can tell A, okay, should be with 3 plus. So if it's A with 3 plus, then we'll be have 2, 8, 3. So most likely A will be AL. Okay. And then we still need to know BCD, okay, because the first one, deduce the type of structures. Okay, we finished already. Suggest what is A and A to D. So B is a covalent compound. B2O3 is a covalent compound. So we will know that, okay, O need electrons. Okay, we need 2 electrons, while B needs 3 more. So that we cross out to get B2O3, okay. If B needs 3 more, that means it will be 285. Okay, so 285, so B should be phosphorus. Okay, while C and D, okay, you find that, okay, both of them, the melting point is different. One is very high, so therefore this one more likely to be GCS, while DO2 should be SMS. Okay, so for GCS, okay, very easy. C should be silicon. Okay, while D, okay, the one who form with oxide, okay, with simple monomer structures, more likely it will be sulfur or chlorine. Both of them should be all right. Okay, so part C, arrange A to D, okay, in order of increasing electronegativity. If you remember, okay, from left to right across the period, the EN is increasing bit by bit. So for question C, okay, so you will have like AL first, and then we go SI, we go P, okay, we go CL, okay, or S at the back. Oh, so D, okay, explain why Al2O3 can conduct electricity in molten state. Because these giant ionic structures in molten state, they contain mobile ions, okay. So when it is melts, okay, the ions inside become mobile, so therefore they can conduct electricity. So basically the question is like this, pretty simple. So now we move on to talk about the acid-base property of oxide of elements from Na to Cl. Okay, so first of all, okay, would like you to remember in a periodic table, the metal oxide formed on the left-hand side are basic. Okay, so those are basic oxide. While the one on the right hand side, like sulfur, like nitrogen, like carbon, okay, when they form oxide, those are acidic oxide. So the property changed from basic oxide, okay, the one Na2O, KO, things like that, okay, go to CO2, SO2. So they changed from basic oxide to acidic oxide. While the one in the middle, okay, they were somewhere in the middle, okay, we call those amphoteric oxide. That means they both shows acidic and alkaline properties. Okay, so for the basic oxide, okay, actually referring to the chemicals that will react with water to form hydroxide. Okay, and they will also react with acid because they are basic. They will react with acid to give salt and water. So the example that we're going to learn is sodium oxide and also magnesium oxide. While the other one, okay, amphoteric, okay, we just have one example here. That is aluminium oxide. Okay, this can react with both acid and alkali to give salt and water. Okay, and the last one is acidic oxide. Acidic oxide for the rest of the giant covalent structures, simple monostructures oxide. Okay, all of these are acidic oxide. If we dissolve them into water, okay, they will give acid. But one exception, okay, except SiO2, because SiO2 is a quartz. Quartz is insoluble in water, so even you put quartz, put sand in the water, they won't dissolve. Okay, so but for the phosphorus pentoxide, like sulfur dioxide, when we put it in the water, they will give acid. And also, if they react with the alkaline, acid and alkaline react together, they also give salt and water. Okay, so these three terms: basic oxide, amphoteric oxide, and also acidic oxide. Okay, so memorize this periodic table, then you can remember, okay, it changed gradually. Okay, so for the first one, basic oxide, just as we mentioned, they react with water to give hydroxide, and they will react with acid to give salt and water. So you, in this section, actually, you just remember each of the oxide and the equations, okay, that is involved. So for example, in sodium oxide, you remember sodium oxide, when they get into the water, they will give NaOH. That's it. Next, if I put it into acid, they will then form salt and water. So in this case, okay, the salt will be NaCl for sure. And then the water, okay, it will be the H with the O. Okay, so this is sodium oxide, the reaction of that. While the magnesium oxide, okay, magnesium oxide, we can also put it in the water. However, it is not really soluble. Okay, slightly soluble only. Okay, slightly soluble. So you'll find that, okay, when we put magnesium oxide into the water, they will produce magnesium hydroxide. While this magnesium hydroxide is slightly soluble, so even you try to put it into the water, okay, it will, ionize to give hydroxide ion, but not that much, okay, comparing to the sodium oxide, it's not that much, okay. But anyway, okay, it can dissolve and give hydroxide, so it is a basic oxide. What's more, when you put magnesium oxide into the acid, if you recognize it is a basic oxide, you react with the acid, okay, the product that you got will be salt and water, okay. So balancing like this, okay. So you just remember each of them, they will have two equations like that, okay. One is reacting with the water, one react with the acid to give salt and water. Next, okay, we're going to talk about the amphoteric oxide. Okay, remember the spelling. Okay, you always see these questions. Okay, in organic chemistry questions. So they can react with both acid and alkaline to give salt and water. You can see the water. I put bracket because one of the equations you really can't see the water coming out. Okay. First of all, you have to remember aluminium oxide. We learned this in corrosion of metals. We learned that, okay, for Al, okay, it is corrosion resistant because on the surface they got aluminium oxide, which is impermeable to oxygen and water. So it prevents the aluminium inside from further corrode. Even it is very reactive, but it prevents from further corrode. So from this one, okay, you have to remember aluminium oxide is insoluble in water. okay, think about the window frame, okay. If it is soluble in water, if the aluminium oxide is soluble in water, when it's just like rainy day, the aluminium oxide will then dissolve, and then the corrosion resistance property will then gone. Is that right? So actually this one is insoluble in water, so you cannot dissolve it in water to give acid, or dissolve it in the water to give alkaline solution. However, it did show both acidic and basic property. Okay, how do we do that? The first one, okay, when aluminum oxide reacts with acid, say for example when you react with sulfuric acid, they do give salts and water. Okay, so they do give salt and water. So this one multiplied by 3, and then you got 3 waters there. Okay, so this one is the acid property. Is the alkaline properties. Okay, because you find that alkaline properties, because you find that they react with the acid. Okay, they give salt and water, and they also got acid properties. You call this alkaline properties, or you call that basic properties, is still alright. Okay. Oh, so when you put it in alkaline, they also react with the alkaline. Okay, so when we have Al2O3, okay, you add into NaOH, and in the process you need to add some water here as well. Okay, then you will have this one, a very complicated one. Okay, it's called sodium tetrahydroxoaluminate. If you have good memory, actually we did see that before. Okay, do you remember long ago when we talk about aluminium hydroxide? If we add excess NaOH, the aluminium hydroxide, which is white in color, it will further dissolve to get a complex ion. Okay, so actually this one is the same as aluminium hydroxide right there. Okay, but the balancing equation, you need some effort to memorize it. Okay, sorry, not yet balanced. Okay, you have to have some effort to memorize this. Okay, so this one is the acid properties, because we see that, okay, it react with the alkaline. So this one is the acid, and then they give out salt. You see, you can't see water, okay, right there, okay, because on the left hand side we do have water. So the water here, okay, somewhere cancel out, okay, somewhere cancel out. So therefore you only see acid, alkaline, water on the left hand side, and the product form is sodium tetrahydroxoaluminate. So this one is AlOH4. Okay, if you remember, this one, okay, is AlOH3, which is completely neutral, the 3 plus and the 3 negative completely neutral. But once you add an extra OH minus here, then the overall charge will then become negative. Okay, if this one is 1 negative here, you just need 1 positive to combine to form a compound, will do. Okay, 1 negative, 1 positive. Okay, this is Na plus, right? Okay, so that's all for the amphoteric oxide. Okay, you have to remember 2 equations. One is the one we add with the acid to give salt and water. The other one is more important. Okay, that will be aluminium oxide react with NaOH, water, and give sodium tetrahydroxoaluminate. Okay, so next, okay, we have a look of the class practice. Okay, so this is the ionic equation writing. You have to practice a little bit. So when the sodium oxide, magnesium oxide, aluminum oxide, all these things are the solid. So do remember, don't change it into ion form. But for the other part, okay, they are acid and alkaline. Then you can put them into H plus and OH minus. Just want to draw your attentions to question D, okay? That will be the one with hydroxide and water and things like that, okay? This will be quite complicated, okay? So I encourage you to work it out, okay, on your own and try it one more time, okay? For ABC, it's pretty simple. You just have the acid add into it, and then forming the metal ion will do. The metal ion will do, okay? So, to summarize, okay, the bonding of oxide of elements in period 3, they will change from ionic compound, ionic bond, to covalent bond. Okay, ionic bond to covalent bond. And this process is because, okay, there is an increase in electronegativity of the elements, or from left to right. When you move to the right hand side, the En get higher and higher. They have a higher, stronger power to attract the bonding electron. While the structure of the oxide, they change from GIS to GCS, which is silicon dioxide. Which is silicon dioxide, and then it go to SMS, simple molecular structure. Okay, for the metal oxide, okay, they mainly basic oxide. Okay, they will react with the acid to give salt and water, and also they can dissolve in water to give hydroxide. They give alkaline solution. While the non-metal oxide, mainly they are acidic oxide. They will react with the base to give salt and water. Finally, okay, the most special one, okay, is aluminium oxide. Okay, the aluminium oxide, they will form amphoteric oxide. They show both acidic and alkaline properties, okay, when they react with the acid and alkaline. Okay, so what you need to do for this chapter mainly is to memorize all the equations that we have learned. So that's all for this part 1, okay. Part 2, we're going to talk about the rest of the giant covalent structure and simple molecular structures. Bye-bye.